inverse functions. Inverse functions. What we have when we're talking about inverse functions is we are talking about how you undo a function to make it the inverse. So here I've got y equals 4x. The inverse of that is y equals x over 4. So if you look at this red line right here, that's my original function. Its inverse function is this blue line right here. Okay? The green line is our identity function. And our identity function is what the inverse functions reflect across. And we'll see a lot more example of that. When I find the inverse of a function, what I have done is I have exchanged the x and the y. Okay, so we're going to look at what that looks like right now. Okay, what I want you to do right now is I want you to find y equals 4x for x equals -2, -1, 0, 1, and 2. Okay? And I'm going to give you a couple minutes to do that. Or actually, I'm not going to give you a couple minutes. I'm going to give you about 1. Okay? What's x equals -2? -8. What about -1? -4. What happens when I plug 0 in? What happens when I plug what in? 2? 8. Thank you. Now, for this one over here, I want you to plug in -8, -4, 0, 4, and 8. So plug those numbers in to y equals x over 4 and tell me what you get. Okay, sorry about that. My boss stopped me in the hall, which is fine. It's all good. Okay, what happened when I plugged -8 in? What did we get?
-2.
Good. What happens when I plug -4 in? -1, right?
Yeah.
Okay, 0,
0,
4,
1,
8,
2.
2. What'd you notice? Yeah, it's interchanged. Okay? My x's became my what? My y. My y became my x's. So this is an important part of inverse functions. A very important part of inverse functions. When I have inverse functions, my domain, okay, the domain of my original function becomes the range of my inverse. And that's going to be super important. The domain of my original function becomes the range of my inverse. Here is my domain for my inverse, and it is my range on my original. Okay? So that is how that works. They interchange with each other. Okay? We ready for what's next? Okay. We're going back to composition of functions. When functions are inverses of each other, when they are inverses of each other, the composition of those functions always equal x. Okay? And it doesn't matter if you do f composed of g or if you do g composed of f. If they are inverses, when you simplify everything out, you are going to be left with x. Now, the algebra on these are a little bit complicated. Okay? The algebra on these get a little bit complicated. What I'm going to do first is I am taking g and I am plugging it in for that x right there. Do you see that? So, what that looks like is f over 5x plus 2. Okay? So I have taken out that x and I've put it in 5x plus 2. Okay? Now I'm going to simplify. Okay? 2 and negative 2 cancel out. Now I am left with 5 over x. This is a complex fraction. Okay? But we can make it less complex. It's not going to be too bad. What does this mean? What does that mean? What does the fraction bar mean? What operation? Division. Okay, so I can rewrite this as 5 divided by 5 over x. Do I know how to do 5 divided by 5 over x? I change my division to what? Multiplication and then flip. Okay? So I do 5 times x over 5. Okay? So I am left with x. Okay? Now, we are going to do the same thing, but we're going to do it the opposite direction. Okay? So I am going to take this and plug it in for that x. Okay? So I'm going to start with 5 over 5 over x minus 2. Okay? Now this time, I can't deal with that plus 2 yet. This time I've got to put that off to the side, and I've got to deal with this first. The 5 over 5 divided by x minus 2. Again, that is a complex fraction. So we are going to make this right there. That means our division. So I am going to have 5 divided by 5 over x minus 2. And this is 5 over 1. Okay? Then I still have this plus 2 out here. But order of operations makes us deal with that 5 over 1 divided by 5 over x minus 2 first. So 5 over 1 times x minus 2 over 5. So then, what am I left with? Good, and I'm going right up here. I think I need a bigger iPad. X minus 2 plus 2. What's x minus 2 plus 2? X. Does it work? Do I get x? So what I have proved through doing this composition of functions is that these two are inverses of each other. That's what I've proved, is that those two are inverses of each Yeah, it simplifies out to be A. And what you'll be asked to do when you have situations like this, it will be either prove that they are inverses of each other, or it will be find out if they're inverses of each other. And it'll give you two functions. You do compositions. You don't need to do both. You don't have to do F composed of G and G composed of F. You just do one. But it doesn't matter which direction you go, you're still going to get X if they're inverses. If you don't get X, then what does that tell you? They're not inverses. That's what that tells you. Good question.
Check these. Do you not plug like any number into f of x and you get an output with your answer, and then you plug that answer into g of x, and you should get the original number you started with?
You would get the original number if you're doing the g of x. Like whatever you get, you plug it into the second one. Yeah, but that's a two-step process, but yes. Okay, so what she's saying is, if I pick a random number and I plug it in for this x right here, and I solve this, okay, I would probably pick 12. No, I wouldn't. I would pick 7. That's the number I would pick, 7. Because 5 over 7 minus 2, what's 7? 7 minus 2, 5. So 5 over 5 is 1. Then you've got to go to the second one, okay? You plug that 1 in right here. What's 5 over 1? 5 plus 2. 7, which is our original number. Good job. Okay. So, horizontal line test. Horizontal line test. Okay? You've heard of the vertical line test. What does the vertical line test tell us? If it's a function, okay? The vertical line test tells us if it's a function. So when we are deciding if something is a one-to-one function, we have already decided that it's a function. So we don't even look at it being one-to-one if it's not a function, okay? So this is a function. We already know it's a function because we've been dealing with functions. What I want to know is it a one-to-one function? And the way that we determine if something is a one-to-one function is the horizontal line test. So I'm going to take a horizontal line and I'm going to drag it down. And if it touches the function in more than one spot, then it's not a one-to-one function. Now, it's still a function. It still follows all the properties of functions. We also can find its inverse. But if a function is not a one-to-one function, then its inverse is not a function. Okay? So for its inverse to be a function, it has to be specifically a one-to-one function. Okay? So this one is not a one-to-one function. So we're going to write, no, this is not a one-to-one function. Okay? Here, is this a one-to-one function? No, it's not. It's not a one-to-one function because we've got this action going on right here. Okay? Because right here, my horizontal line doesn't pass. So, this is not a one-to-one function. This one is a one-to-one function. Now, we've got some asymptotes over here that we're dealing with. We've got an asymptote at 0 right here. And we are approaching 0, but we never cross. And we're approaching 0 here, but we never cross. Because if I plug 0 into that, what happens in my denominator? What do I have in the denominator if I have 3 times 0? 0. We're not allowed. That's something that's not allowed to have 0 in the denominator. So this is a one-to-one function because that line is approaching that asymptote. The closer that we move to infinity, it's approaching. But it never gets there. So this is a one-to-one function. Even though it looks very vertical, it's not quite vertical. Okay, so those are some graphs. What we're going to do next is we're actually going to find the inverse of a function. And there's some steps that we follow when we find the inverse of a function. Okay? So the first thing that we do is we replace f of x with y. I knew I was going to do that. Okay, we're just going to move my width down to the next line. Okay, replace f of x with y. Okay? Second thing we do is switch x and y. We're going to switch x and y. Third thing we do, solve for y. Fourth thing we do, replace y with f inverse of x. Okay, so these are our 4 steps. These are our 4 steps. Okay? Step 1, replace f of x with y. So I'm going to have y equals 5 minus x over 3x plus 2. Okay? So I've replaced f of x with y. Now I'm going to switch x and y. Typically, students don't have any trouble with this. Okay? So I switched x and y. Now, my third step is that I've got to solve for y. I've got to solve for y. Okay? Now, think back to when we were solving things like 4 equals x over 2. How would I get rid of that denominator? Multiply both sides by 2. Okay, so multiply 2 over 1 times 2, and those simplify out. So I'm left with 8 equals x. That's what I would be left with. That's what we're going to do here. We're going to multiply both sides by 3y plus 2. Oops. (3y plus 2). Okay? Then my 3y plus 2 on the denominator and then the 3y that I'm multiplying by simplify. So on the right-hand side of my equation, I'm left with 5 minus y. Now I'm going to rewrite this because I kind of squished it. What do I have to do with that x? I've got to distribute. I've got to distribute the x. So I have x times 3y. So that's going to be 3xy. Then I've got x times 2. Okay. Now, we're still on step 3, the solve for y. What students want to do, or what they like to do, or what some students do, is they're like, well, there's my y right there. It's already kind of isolated, so I'm going to subtract 5 from both sides, and I'm in good shape. Okay? The problem with that is what do I have right here? Another y. So I can't do that. But that is the number one mistake I see, is that students are like, ooh, there's a y, I just have to solve for that. Okay? But that's not what we're doing. So, what I have to do is I have to get my y's on the same side. So I am going to subtract, or I'm going to add, not subtract. The reason I'm adding is because I've got a negative y. So I am going to add y to both sides so that I can get my y on the same side as that other y. That's my plan. So now I have 3xy plus y plus 2x equals 5. Okay, I'm going to rewrite this. What's my next step? What do I need to get to the other side with the 5? So here I've got 3xy. That has a y, so I need to keep it. This has a y, so I need to keep it. Does that have a y? No, so I need to subtract 2x and get it over here. Okay? Okay. Now, what we have to do is I've got to factor out this y. I'm going to factor it out. I'm going to pull out the y. Okay? I'm doing the opposite of the distributive property. I'm pulling that y out. So I have y times 3x plus 1. Okay? How do I isolate y completely? Divide by 3x plus 1. Okay, so the algebra is a little bit intense. Okay, so my final answer is y, well actually it's the final part of step 3. Y equals 5 minus 2x over 3x plus 1. That's the final part of step 3. That is my inverse function. So what I have to do now is very minor. I take away my y. I put in f inverse of x. So I have 5 minus 2x over 3x plus 1. And I know that that is all over the place. And I am sorry. I really do need a bigger iPad. Okay, is that good? Can you see it right there? Okay, now, this is what it looks like. There's all sorts of cool stuff that we're looking at here. Okay, here is my identity line right here. My identity function is what it's called. Red is my original function. Do you see the red graph? Okay, blue is my inverse. So if I folded my identity line, they're a reflection of each other. Okay, notice that the functions cross at the identity line. Okay, the functions cross at the identity line. Okay, now we're going to do some other stuff. We're going to find the domain of the functions and the range of the functions. And it's always helpful for us to review domain and range. Okay, so my original function is f of x equals 5 minus x over 3x plus 2. That's my original function. F of x equals 5 minus x over 3x plus 2. It is a rational function. That means fractions are involved, and I have a variable in the denominator. I am not allowed to have 0 in the denominator. Can I plug 0 in for x? Maybe. But what's in the denominator cannot equal 0. So I have to take 3x plus 2 and set it equal to 0 to find out what x can't be. So now I solve. We had one similar to this on your quiz. So what is it that x cannot be? Negative 2/3. So my domain for that is negative infinity to negative 2/3 union negative 2/3 to positive infinity. Now, if that is the domain of f of x, what is it it for f inverse of x? Okay, so let's go back to our ordered pairs. There we are. The domain of f of x is what on f inverse of x? Okay, here's my domain for f of x. Where does it show up on inverse? The range. Okay, so the domain of my function is the range of my inverse. Okay, so that's going to be right here, negative infinity to negative 2/3, negative 2/3 to infinity. Okay, now f inverse of x, let's do that in a different color, just because we can. F inverse of x is 5 minus 2x over 3x plus 1. 5 minus 2x over 3x plus 1. We're still dealing with rationals, so I'm still focused on the denominator. So my denominator, 3x plus 1, cannot be 0. So I have 3x equals negative 1. X equals negative 1 over 3. Okay. So now I've got negative infinity to negative 1/3 union negative 1/3 to positive infinity. My domain of my inverse is what to my original function? Range. Okay, the domain of the inverse is the range of the original function. Okay? Now, the algebra associated with this particular type of problem is a little bit challenging. I mean, you'll definitely see more difficult algebra in your life, but for right now, that's the most difficult algebra we're going to deal with. So you need to come back and look at that so that you make sure you know how that algebra worked. Okay? Here's our graph again. So let's do another one. This one I like a little bit. I think you'll like. So we're going to find the inverse of this, but the first thing that we've got to decide is this a function? And we decide if this is a function with the vertical line test. Okay, so I take this. Does it pass the vertical line test? Yes, it does. It passes the vertical line test. So yes, this is a function. Then we have to decide if it passes the horizontal line test to determine if it's a one-to-one function. So does it pass the horizontal line test to determine if it's a one-to-one function? Does it pass the horizontal line test? It does, okay? So this right here never becomes exactly vertical, okay? It keeps getting wider and wider. It's very minute, but it does. Okay, you're really looking for the loops and stuff, or the hills and the valleys, the maximums and the minimums. That's when it's not a function. Okay, so yes, this is a function, and yes, it's a one-to-one. Okay, so it's a function and it's a one-to-one function. Okay, so we are going to find the inverse of it. Because it's a function and it's a one-to-one function, we're going to find the inverse function of it. Okay? So, first thing I do, replace f of x with y. So I have y equals x to the third minus 4. Second thing I do is I switch x and y. So then I have x equals y to the third minus 4. Okay? The third step, and this is where sometimes we get uncomfortable. Now we solve for y. Okay? We're solving for y. The way I solve for y is I add 4 to both sides. I've got x plus 4 equals y to the third. How do I undo y to the third?
The third root.
Good. I'm going to take the cubed root of both sides. Okay, that's the cubed root. So I have the cubed root of x plus 4 equals y. And so that is my inverse function. F inverse of x equals cubed root x plus 4. Okay? The algebra is not as intense on that one, but we do need to make sure we understand some concepts about x to the third. Okay? First, let's go ahead and look at this. I think this is cool. This is a good graph of inverse functions. Our green line is our identity function. Okay? It's y equals x. My red line is my original function. X to the third minus 4 is a translation of x to the third. And if you think back to what we did on Tuesday, you'll remember that because of the minus 4, we just move it straight down 4. That's what we do. You just move it straight down. Okay, so that's what's happening here. The inverse is y equals the cubed root of x plus 4. That's the inverse of that. That is my blue. Now, first thing I want you to see, they cross on the identity line. Okay? They cross right there. Now, my x-intercept of my inverse, here's my inverse function. Do you see that? That's my x-intercept. It's the y-intercept on my original function. Okay? Then, here my x-intercept on my original function is my y-intercept on my inverse. Okay? So lots of really cool things going on there. Now, before we find the domain and range of this, I want to ask you, what is negative 2 raised to the third power? Negative 8. So if I wanted to take the cubed root of negative 8, what would that be? It would be negative 2. So when I go back here, sometimes students will ask me, Alicia, when we took the cubed root of both sides of this, why didn't I put plus or minus right here? Okay? And the reason for that is, this is an odd index. Okay? This is an odd index. If I've got a 5 here, if I've got a 7 here, it's okay for me to have negative numbers in here. We have to do the plus or minus when I'm taking an even index. The most common is the square root. So for this, if you are looking at this graph, if we are trying to decide on the domain of my red graph, okay, and remember, my domain keeps coming out all the way, and then the red graph keeps going up, and it's going to keep going this way. What's the domain of my red graph? Negative infinity to positive infinity. It's all real numbers. Okay? Because I can have negative numbers inside a cubed root, or a fifth root, or a seventh root. It's the square. If I'm taking the square root, or the fourth root, or the sixth root, that's when I can't have negative numbers. So, my domain of my original function is negative infinity to positive infinity. So if the domain of my original function is negative infinity to positive infinity, that means the range of my inverse is that. Okay? What's the domain of my inverse? That's the blue one. What's the domain of that one? Negative infinity to positive infinity. Okay?